Welcome to Study Loop.
Hello everyone, today we're doing chapter 29, problem 2, and this problem asks us to determine what form exists at the isoelectric point of each amino acid. So the isoelectric point, or the pI of an amino acid, is the pH at which your net charge on your amino acid will equal to 0. However, the molecule will exist in its ionized form. What does that mean? That means that groups that are ionizable, such as the alpha amine group and the carbonyl group, the carboxylic acid group, these groups are going to exist in their ionic form. However, the net charge of the amino acid will be 0. So at the pI for A, which is asks us for valine, well, we can draw our typical NCC backbone. So we have nitrogen, NCC, 2 carbons. And we know at the end of the carbon, we have the carboxylic acid. In the middle, we have the R group. And valine, if you remember, well, valine looks like a V. So valine is a V. But now at the isoelectric point, the ionizable groups will be in their protonated or deprotonated form. So we know the carboxylic acid is acidic, so it's going to be in its deprotonated form as O-. And the nitrogen, being basic, will pick up an extra proton being in its protonated form as NH3+. So here we have a positive charge and negative charge. So we have a charged species here, but the net charge is going to equal to 0. Now for B, we see that the problem is asking us now for leucine. So now if I draw my NCC backbone, we know right away that these groups will exist in their ionizable form. And now here, if we were to draw leucine, well, we know leucine has 4 carbons. So we have 1, 2, 3. And if we count here, so we have now 1, 2, 3, 4. So leucine looks something like this. Isoleucine kind of looks like an I, so you could imagine isoleucine being something like this, while leucine just looks something like this. In C, we have proline. So proline is an interesting amino acid, such that the alpha carbon and the amine group are now cyclized together. So we can just draw a simple cyclopentane here. And right off the bat, you can see that now nitrogen has 2 bonds, but we need 2 more bonds to make it positively charged. And obviously the carboxylic acid will remain negatively charged, and this gives you proline. And what you notice here is that the R groups here, valine, leucine, proline, the R groups here are non-ionizable, so we don't have to have any concern about them. But now in problem D, it asks us for glutamic acid, and glutamic acid has an ionizable side group. So if I were to do the same thing as all the other problems, so I draw my nitrogen in this protonated form, carboxylic acid as a deprotonated form, I have 1, 2, and then we have 1, 2, and 1 more carbon in which the glutamic acid will come off of. So here we have another carboxylic acid. So let's remember what the terms at the pI, the isoelectric point, is the pH in which your amino acid will be in its ionized form. However, the net charge will equal 0. So all of these problems here is pretty easy. The nitrogen would pick up a proton becoming positively charged. The oxygen or the carboxylic acid will lose the proton being negatively charged, plus a positive charge plus a negative charge equals 0. So this existed through A, B, and C. And now in D, we still have that same methodology going, but now the R group here is also ionizable. So what happens if this doesn't have a proton, it's negatively charged? Well, then the overall charge of this amino acid, glutamic acid, would become -1. So then it would become a fully charged species. However, at the pI, we know that this is going to be neutral, and the net charge will be neutral. So because of that, we know that in order to not have any charges added on this molecule, we need to have the R group or the glutamic acid group in its protonated form.